In this video, I'll show you how to calculate monthly payments at varying amortization periods. This is question 3. The question reads, determine the monthly payments on each mortgage. Assume each payment is compounded monthly. So we have mortgage A, B, and C, all for $200,000, but as the amortization periods increase, the interest rates also increase. Let's tackle A. What do you notice about the interest rate as the amortization period increases? Well, we just answered that. As amortization period increases, usually banks will start to charge more interest. Let's move on to question B. What do you notice about the monthly payments as the amortization period increases? So this time they want us to fill out this part of the table. To do this, we'll need to use the present value formula. And the present value formula is shown to your right, and the letters for this formula are defined below. The principal borrowed will represent our PV, and that's not going to change for all three of these plans. So let's write that down. PV is equal to $200,000. What we are looking for here is the monthly payments. So essentially we're looking for R, and luckily for us, I do have a version of this formula where R is already isolated. So I'll be using this. For case A, so I'm going to call this IA, our rate will be 5.25% divided by 12 because it is monthly, divided by 100 because we're going from percentage to decimal. For IB, we have 6.75 divided by 12 divided by 100 for the same reason. And for IC, we have the percentage being 8.5 divided by 12 divided by 100. At the same time, N for this case will be 15 for the number of years times 12 months in a year, and this gives us 180. N is equal to 20 years times 12, and that gives us 240. And N for this case, we have 25 years times 12, and that gives us 300. So I'm going to use my calculator for all three of these cases, and I'm going to show you the first one, and it's the same thing for B and C. So here's the first one, 5.25 divided by 12 divided by 100. And this gives us, perfect. So let's do the same thing for these, and I'm going to fast forward this. So there you have it. Those are the I values for each of these cases. I'm going to call this specifically case A. And I'm going to show you the calculations for case A, and then you can use the same method for B and C. So for case A, we have R, which is representing our payments every month. And at the top, we have our PV, 200 times your I value of 0.004375 divided by 1 minus 1 plus this number to the power of negative 180. Now, in case you're confused, all I did was plug in everything I know into this formula. So I'm going to use my calculator now. 200,000 times 4375 divided by 1 minus 1 plus 0.004375 to the power of negative 180 gives me $1,607. $1,607.75. Now, if you remember, the chart above also asks for the total payments. So to find the total payments, you'll take your monthly times the number of payments that you'll make, which is 180. And this gives us $289,395. $289,395. Now we can fill in the chart above. So for this first slot, I'll say 1607.75. And over here, I'll write down 289,395. I'm going to fast forward the process. I'm not going to show you case B and C, but it's the exact same calculation. And if you do the calculations right, these are the numbers that you should get. So there's the chart all filled out. Now make sure that you recognize that this is in dollars. And for question C, they ask, what do you notice about the total payments as the amortization years increase? Now you'll notice that as the borrowing years increase from 15 to 25, the total payments will significantly get higher, paying roughly $1,600 every month. And it is at 5.25%. The total payments at the end of those 15 years will be $289,395, which is technically $89,000 more than you borrowed. But as you borrow for a longer period of time, the total cost of the house will go up significantly higher. Now take a look. If you take 20 years, you'll be paying roughly $162,000 more than what you originally took at $200,000. And lastly, the worst one being the higher you amortize, the more you'll end up paying. So you will actually be paying double the house if you take a mortgage for 25 years. And so there you have it. That is how to calculate monthly payments at varying amortization periods. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.